Good morning students, I am back with the new chapter, that is chapter 1, physical quantities and measurement. Actually this chapter consists 3 units. These are based on area and its measurement, volume and its measurement, and measurement of density and speed. That means in this chapter we will discuss about some scalar or and derived units. Okay, so key points of today's class are measurement, that means before starting the measurement of area and its units, first we will see what is exactly the measurement. Okay, the measurement of area and its unit, some multiples and multiples of standard units of area, formula to find areas of some regular surfaces, measurement of area of an irregular flat surface. So here I am going to start our first unit, that is unit 1.1, area and its measurement. Okay, as we know that in our previous classes already we have learned about the measurement and the measurement of the different quantities. Okay, in physics we deal with a large number of physical quantities like length, mass, time, velocity, force, pressure, speed, etc. These quantities can give clear understanding only if we can measure them. Without measuring them, we can't understand these quantities, okay, and express our conclusion into these measurement. For this reason, physics is sometimes called the science of measurement. For example, suppose we want to measure the length of a rod, okay, so we have to take that meter scale or the scale to find its that length. Okay, suppose the length of that rod is 3 meter. Similarly, suppose we have to find the mass of any body and the mass of any body is 2 kilogram. That means that the unit of mass is kilogram and this unit is contained 2 times in the mass of the given body. So for the measurement of a physical quantity, we considered a constant quantity as a standard and then find the number which expresses how many times the standard quantity is contained in the physical quantity. Okay, so measurement is the comparison of the unknown physical quantities with the known fixed unit quantity. Okay, so before explaining about the measurement of different quantities, we should know about the measurement. We should know the definition of the measurement. Okay, so measurement is the comparison of the unknown physical quantity with the known fixed unit quantity of the same nature. We have already learned measurement of area in our previous classes. Let us revise it and find the area of the irregular surfaces. As we know that area of a door is more than that of a window. Similarly, the area of a table is more than the area of a chair. So how can we make that statements with the assurance? Okay, well, we must be able to measure the area. So before we learn how to measure the area, let us try to find out what do we really mean by the term area. So the area is the amount of surface occupied by an object and place is called its area. So to find the area of different object, we will perform this investigation, and this investigation is to find the area of the table and of the chair. We have to place the physics book on the table side by side as shown in this figure. Now let us suppose that 4 physics books cover the complete surfaces of the table. You can see in this diagram, the 4 physics book cover that complete surface of that table. Okay, thus the area of the table will be equal to the area of this 4 physics books. Now we will go move to that chair. Now place the physics book side by side on the chair. Now let us suppose that 2 books cover the complete surface of the chair. Thus the area of the table is equal to 2 times of the area of the chair, because in the surface of the chair is covered by 2 physics books only and the surface of the table is covered by 4 physics books. So what will be the conclusion of this investigation? So conclusion is here, area of table is more than the area of chair, you can see in this diagram after performing this investigation. And the second conclusion is the area of table is twice the area of the chair, or we can say that the area of table is equal to the 2 times of the area of chair. Okay. So for measuring area, we must have some standard units. The physics book which we use to measure the area of table or chair are not the standard units. So if we will use this, we will sound like a foolish. So suppose that if we are saying that the area of your table is equal to the area of 4 physics books, as different physics books will have different areas. So we should have some fixed units to find that area. Okay, so now we will talk about the units of area. As we know that area is the scalar quantity, that means for describing the area there is no need to mention that direction, only magnitude or the numerical value is needed. Okay, so units of area in the standard international system, or we can say the SI system, the unit of area is square meter, or in short form we can write it m to the power 2, or we can say that the abbreviation can be written in that way. Okay, now the question is that how big 1 square meter is, that means what is exactly meter square. So here we have to define meter square. The area of a square surface whose each side is equal to 1 meter is called 1 square meter. You can see in this diagram 1 square is given here whose each side is given as 1 meter. Okay, that means you can see AB is equal to BC is equal to CD is equal to DA is equal to 1 meter. So the area of this surface enclosed by this square ABCD is 1 meter square. Okay, this you should know about that meter square. Many times it is asked that what do you understand by the meter square, or define the meter square. So this you should know that meter square is the SI unit of area, and it is the area of a square surface whose each side is equal to 1 meter. Okay. As we have seen, the square meter is the SI unit for measuring area, but however it is quite an inconvenient unit for measuring the surfaces of small objects like a physics book or an instrument box or anything, okay, which is having the smaller area. So it is also inconvenient to measure the surface area of very small objects such as a 5 rupee coin or a shaving blade, etc. Thus we use smaller units for measuring such areas, and such units are called the submultiples of standard units of area. So now we will see that the submultiples of the standard unit of area, that is meter square. Okay, so smaller units which are used to measuring the area of small objects, these units are called the submultiples of standard units of area, that is meter square, and these are millimeter square, centimeter square and decimeter square. Okay, so here we will see the conversion of these units also. That means 1 millimeter square is equal to 1 upon 100 centimeters square. Okay, 1 upon 100, that means we can write it 10 to the power minus 2 centimeters square. In that way, in decimeter, it will be 10 to the power minus 4. That means 1 upon 1000 decimeters square. Or in meter square, it will be 10 to the power minus 6 meter square. So you can convert this units from millimeter square to centimeter, then decimeter, then meter. Okay. Now next one is the 1 centimeter square. 1 centimeter square is equal to 1 upon 100 decimeter square. 1 upon 100 decimeter, that means 10 to the power minus 2 decimeter square, and in meter square it will be 10 to the power minus 4. These all are called the conversion. Conversion, that means here we are converting the unit centimeter into decimeter, decimeter into meter. Okay, our next submultiple of meter square is decimeter square. So 1 decimeter square is equal to 10 to the power minus 2 meter square. So here this is all about the conversion of the submultiples of meter square. When you will solve this, you will get this only. Okay. So these all are the submultiples of meters, and these are millimeter square, centimeter square and decimeter square. For measuring bigger areas such as the area of a big plot of land or the area of a town or city, etc., meter square is a little bit small unit. Okay, so a bigger unit is required here, such as air, hectare and square kilometer. So for measuring bigger areas, some bigger units are used for measuring bigger areas. These are called the multiples of standard unit of area, that is meter square, and these are air, hectare and kilometer. Okay, actually kilometer and kilometer and the hectares, you all have heard about it before, but air is something new for you. So what is exactly air? So 1 air is the surface area of a square whose each side is equal to 10 meter. As we have seen in the when we were talking about the meter square is the surface area of that particular square whose each side is equal to 1 meter. In the same way, we can define 1 air is the surface area of that particular square whose each side is equal to 10 meter. You can see in this diagram, one square is given here whose each side is equal to 10 meter. Okay, so air is the surface area of this square. Clear? So in that way we can say that after converting 1 air into meter, 1 air is equal to, by putting the formula, length into length, length into length, that means side into side. This is the formula of the area of square. Okay, so here it will be 10 meter into 10 meter. So after multiplying it, we got that 100 meter square, or that means 1 air is equal to, in meter square it will be 100. 1 air is equal to 100 meter square, or 1 meter is equal to 1 upon 100 air, or in that power form or in the exponent form we can write it 10 to the power minus 2 air. This is called the conversion. Okay, here we converted that air into meter square and meter square into air. Clear? Similarly, about 1 hectare is equal to 100 air. So 100 into 100 meter square. So in this way 1 hectare will be 10 to the power 4 meter square. Okay, 10 to the power 4, that means 10,000 meter square. So 1 hectare will be 10,000 meter square, or 1 meter square is equal to 10 to the power minus 4 hectare. This is the conversion, how we can convert one unit to the another unit. Okay, so this is hectare and air are the multiples of standard unit of area, or that is meter square. For measuring further bigger areas such as the area of a district or a state or a country, even hectare and air are very small and inconvenient units. As we have seen when we were talking about that meter square and 1 air, that time we have seen that they are the surface area of that particular square whose side is equal to 10 meter in the case of 1 air, and 1 meter in the case of meter square. Okay, but here 1 kilometer square is the surface area of that particular square whose each side is equal to 1 kilometer. You can see in the diagram here, one square is given whose length of each side is equal to 1 kilometer. Okay, so in that way we can change it into meter also. 1 kilometer is equal to 1000 meter into 1000 meter by changing it into meter square. So here 1 kilometer square will be 1 lakh meter square. That means this is called the conversion from kilometer square to meter square. Okay, in the same way we can change it into kilometer square to hectares, and it will be 100 hectares, and hectares to acres, that is 100 into 100 acres, that is 10 to the power 4. Okay, so 1 kilometer square is equal to 100 hectares, and 1 kilometer square is equal to 10 to the power 4 acres. These all are called the conversion. Okay, you should know about this, how to convert sub multiples into multiples and multiples into sub multiples by multiplying or dividing. Okay, so this was all about that multiples and sub multiple units of the standard unit of area. Now we will see the formula for calculating the areas of some regular surfaces. Regular surfaces, that means the surfaces which is having the fixed shape. Okay, like square, rectangle, triangle, circle. Okay, so our first shape is, you can see here, this is the circle. So what is the area of the circle? The area of circle is pi r square, where pi has the constant or the universal value. You maybe you have seen in your mathematics subject, that is, it is having the universal value 22/7 and 3.14 in that decimal form. So r is the radius of that circle. So pi r square is the area of circle. Now the area of triangle is half base into height. Base you can see here, and height also you can see in that diagram. Okay, so the area of triangle is half b into h. B is denoted for base and h is denoted for height. Our next surface is the square. So the area of the square is side into side, or we can say that length into length. Okay. Our next shape is the rectangle. So the area of rectangle is length into breadth. Clear? Here it is denoted by W, but usually we just take it breadth B. Okay, so area is equal to length into breadth, where L is denoted for length and B is denoted for breadth. Okay, now the parallelogram. Maybe this is new for you. Parallelogram is a kind of quadrilateral. Okay, so which is having that opposite sides are equal and parallel. You can see here. So what will be the area of parallelogram? It will be base into height. You can see what is the base in the parallelogram and what is the height in the parallelogram. Okay, so in that way you can find the area of that particular object which is having the shape of that parallelogram. Okay, now this is the trapezium. Trapezium is also the kind of quadrilateral. So the area of trapezium is half a plus b into height. Okay, where a and b are the opposite sides. Okay, so these sides are parallel, not equal. Okay, so where a and b are the length and the parallel sides, and h is the perpendicular height. So these are all about the areas of some regular surfaces. This you have to learn or remember. Okay. So for finding the measurement of area of an irregular flat surface, suppose I am finding that area of that leaf. You can see that leaf which was available at my home, and we will find the area of this leaf by this graph paper. Okay, this graph paper, this rough graph paper, you can see I have made for you to find that area of that leaf. So what we have to do to find the area of that leaf? We can find the area of any of the leaf by the graph paper. Okay, so we have to place that leaf on that graph paper. With the help of the pencil, we have to mark the outline of this leaf. You can see I will mark the outline of the leaf with the help of pencil. In that way, you can see. So now we will remove this leaf from that graph paper, and we will see that it is the that outline of that leaf. Okay, now what we have to do next? We have to count the number of the complete squares enclosed by this face of leaf. So we will number that complete square in that way. Suppose this is not the complete square, this is also not the complete square, this is also not the complete, these all are not the complete square. So we will numbering on that squares only that are complete by this enclosed face of leaf. So here 1, then 2, then 3, then 4, then 5, then 6, then 7, 8, 9, then 10, then 11, then 12, 13, 14, 15, 16, 17, 18. These squares are not completed. Okay. Then 19. It is not complete. It is not complete. So total number of the complete squares are, so number of complete squares is equal to 19. Now we will tick the squares, those who are not completed. That means 1, 2, 3, 4, 5, then 6, then 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, then here also it is 18, 19, 20, 21, 22, 23 and 24. So number of incomplete squares is equal to, again we will count it so that confusion will not be there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. That means number of complete squares are 19 and number of incomplete squares are 24. Now what we have to do with this complete square and this number of incomplete squares? We to find the area of this leaf, what we have to do? We have to put one formula. So the area of the leaf is equal to number of complete squares plus number of incomplete squares into half. Okay, this is the formula which we have to put to find the area of any of the leaf. Now we will put the values. Number of complete squares are 19 plus number of incomplete squares are 24 into half. Okay, so after cutting this, 19 plus 12, and here we have to write the centimeter square because this is the centimeter graph paper. Okay, so 19 plus 20, 19 plus 12, that is 31 centimeter square. So the area of this leaf will be 31 centimeter square. In that way you can find the value of the leaf of or any of the leaf which is available, or you can find the area of any irregular surface, suppose the coin, or suppose you can take any other leaf of any plant like rose leaf you can also take, but you have to remember that if the leaf is small, so you have to take the millimeter graph square. Actually it is centimeter graph square. Okay, so in that way we can find the value of the leaf, or we can find the value of the area of the leaf. It can come, the area can come in that point way also, like 31 point something or 32 point something. That means no need to find the area in that whole numbers. Okay, So in that way, you can find the area of any of the irregular surfaces. I hope you understood the explained topics. In this unit, I am not going to explain that back exercise because now it is going difficult for me to put everything in a single class. So thank you and have a nice day.